Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host Shafu, and today's episode is with ultrasecr, who's gonna walk us through contango v2. Ultrasecr, thanks for taking the time, dude.
Thanks for having me.
Yeah, sure.
Um,
So why don't you briefly introduce yourself, introduce your project, and then jump directly into the code?
so yeah, I'm ultrasecr. Been a dev for about 20 years now. Got into Web3 for the second time in 2020. Um, and yeah, for the past couple of years, I've been working with Contango, which just released our V2. Um, Contango is a financial term that comes from when a futures price is above the spot price, but this only apply for dated futures, which is what, or expirables as we call them, which is what our V1 was all about. Uh, for V2 at the moment, we are mainly focused on perps. So there is no contango in the perps, but yeah, the name will stay. Um, in case that uh, people haven't seen our app, I'm going to briefly show it. So the smart contracts actually make sense. So what we do is to facilitate trading
Yeah,
of,
we
so
can only
yeah,
see VS Code right now.
right. Okay, wait a second. They may have shared just, no, this one. All right,
VS
no,
Code, VS Code again.
this time I've shared the full screen. What? Of course, this thing never works. Uh, okay, let's do it again. No, okay, entire screen. Okay, my fault.
No worries.
All right, now it should work. Let's hide this. And so yeah, so as I was saying, I think it's easier to introduce the product and the smart contract by looking at the UI first. So what we do and what we did in V1 as well is to facilitate the trading of futures, and in this case, perps or expirables. They are not technically futures, but like it's the term that is the most similar for the wider audience. And so what we do is to synthesize the cash flow of a perp in this case by borrowing and lending on existing money markets. So in this case, we are slowly rolling out. We are still sticking to Aave, but we are rolling out different chains. And we have the code for at least 2 or 3 different other money markets that we haven't released yet. One of them is already audited. It's just that we are waiting for some UI features, and then we have a couple more that are work in progress, and we will be auditing soon. And yeah, so the idea is that you come here, you say, I want to open, I don't know, a 3x lever position on if die. I can see the rates I would be paying in this case because it's negative in each one of the chains. I just choose the chain. In this case, I'm going to stick to Arbitrum because I have money there. And what we are looking here is searching for the best spot price using the mean finance aggregator. This will come handy later when we look at our public API. And so this is saying that if we pay $50, 50 DAI effectively now, we can 3x to get a position worth 0.1 ETH. So this means that our position is going to be worth roughly $150, $160 because it's 3x. So it's effectively three times this much. So we implement permits whenever possible. And for other chains that they don't have permits in most of the tokens, we are working in adding permit 2. that we will see in the API layer. So I just create something. This shows up here now. This is waiting for like the graph to index this, so sometimes it's not the most responsive, but it will show up as something here. Okay, that's it. Then in order, like, first of all, like this is not something that is strictly new. It's like since the beginning of time, you could do this with Maker, but you would have to do it manually, right? You would have to, I don't know, deposit ETH, borrow DAI. Now with that DAI, I go and I buy more ETH, and then I put that this as extra collateral, maybe borrow more DAI, do that again and again. That's why people call it looping sometimes, or folding. You can do this with Aave, you can do this with Compound, you can do this with any money market. And so like the advantage to do it with Aave, for example, is that you also get paid when you deposit your collateral, right? So when we open a position that is worth like 1 ETH, we deposit the ETH first, of course. So we use a flash loan to bridge the gap, and then that ETH is going to be yielding interest. And when we borrow part of the cost of that ETH, the other part comes from the money that the user is depositing, then we are paying interest on that. So depending on the dynamics of the market, you can be paying more than what you're getting paid for depositing your ETH, or vice versa. And that means that same as in the perps, your APR, which is more or less like the funding fee in a perp, can be negative or positive. I say more or less because the amount of interest you pay depends on how much leverage you use. Like the lower the leverage, the lower we borrow, then it's more likely than the interest for giving your ETH to Aave will offset the interest of paying for it. So all of those dynamics are in play. But the beauty of this of what we did in V2 is that all of that, for the purpose of the smart contract, doesn't really matter. So like in V1, we put a lot of logic in the smart contracts, and they were like taking care of accounting and taking care of like everything. We wanted like the smart contract to be the center of the application. And that was really restricting, and that was really problematic. And it's a problem because on one hand, you don't want to upgrade your contracts ever, if possible. But on the other hand, you have to react to feedback of your users and the market and whatnot. So we went back to the drawing board, and we started thinking, because we like myself and my partners, we've been building financial software for a while now. Like we did a lot of CeFi exchanges, RFQ platforms, and order routing, you name it. And the thing that we realized is that in a lot of the CeFi world and TradFi world, there is a clear distinction between what happens in the trading UI, what happens in the execution, and what happens for settlement. And if anybody, like if you ever read about a blockchain, like the settlement words comes very often. So the settlement means like the blockchain holds the truth and is the one that decides who owns what. So of course we didn't go the full way like the YDX, where like they do the trading off chain and then they just do settlement on chain, but we went halfway, which is we execute on chain, like the chain has the balances and everything, and that's it. And we don't even store our own balances on chain. We rely on the money markets for that. So this means that a lot of the logic we are going to see is just about execution, like everything related to interest rate calculations, everything related to order routing, and everything like that is performed off chain. So there are like two main interfaces that we use. Like we have Contango, which is the entry point to the main contract of the application, and it's an extremely simple API. You can trade and you can trade on behalf of. And then we have claim rewards because we haven't released a money market yet that exposes this. But if for some reason, it's very common that you deposit money or you borrow money in, I don't know, Sonne or Exactly or Aave in the past, or Aave in Avalanche. We haven't got to that yet. The thing is, like, you're going to get rewarded with Avalanche tokens, OP tokens, protocol tokens, whatever. And what we will do in that case is that we will forward those rewards directly to the user. So you'll have a nice button in the UI to claim the rewards, and we will integrate that with the APR. So you will see, like, even if you're paying some interest, you're going to be getting some tokens as a reward. So trading with us in the end could even have, like, you can get paid to trade. But other than that, that's the only thing that the main contract does. Is you need to be able to trade, okay? And so looking at the implementation of this contract is a very long one. Something I really hate about smart contracts is that because of, like, the constraints of the language and mostly like gas, you can't do all the abstractions that you would do in a normal language, right? Like Java or Scala or whatever. And I've always been a maxi of having code that reads like a book, so I don't have to write comments, because I feel like a comment is is a red flag for me. If I have to write a comment, it's because, like, I should abstract this in a function or in a different class and whatnot. And of course, big classes are also like a red flag, but I learned that with Solidity, sometimes you have to put that aside, and your contract may be long, and you may have comments every now and then because it's cheaper to write a comment that, having an extra jump or having to call a third party because gas. So, yeah, just a warning, this contract is like 800 lines, and that to me is a lot. So as you have noticed, like, we have globally defined structs here, and they are in the interface because they are part of the public interface. And we also split the interface in three. So we have contango events and contango errors. Like, we don't strictly need contango errors as a separate thing, but actually, I think right now we do. Anyway, the reason why we do this is so we can, on our tests, we use Foundry all over the place. And, it's really annoying that you cannot access events from a different contract because you can only share events through inheritance. So by separating the events in a different interface, we can go into a test and say, hey, you are a test, and by the way, you extend this interface. So then we can do assertions and say, hey, yeah, this contract, this event has been emitted, yada, yada, yada. For the errors, we didn't have them separate, but if I remember correctly, we ended up separating them because in the end, the main entry point of Contango is not Contango itself, but this contract I decided to name Maestro until I could find a better name, and it never happened. So, the Maestro is the orchestra director in tango. So, yeah, quack. But it sticked. So, because this is the public interface, and, like, this is what everyone is going to be consuming, and because, the ABI is somewhat crappy sometimes. Like, when you compile an ABI of a contract, you get, like, all the functions and all the errors and all the events, but you don't get anything about what that contract is calling, right? And that's a problem, because then you are working and you get an error, and so the tooling doesn't know how to parse that, and it's like, oh fuck. So yeah, so what we did is, like, this Maestro it's an orchestra director, right? Like this maestro will orchestrate the interactions in between contango, which is the main contract, the vault, which is where we may temporarily store user funds. We'll get to that, and the order manager, which is the entry point for automation, limit orders, and whatnot. So yeah, we have this nice split, so we can then say the maestro has these errors even if they are not their own. So when we compile the ABI, we have a nice like the UI knows what's going on, right? If something blows up, if it is one of our errors, the UI will know. And this track that we define inside a contract is because this is effectively private to contango, and it should not be used by externals. So we put them inside here. This is something we store, and that's why we call it storage. And we do this because we made the big mistake in V1. I mean, it's a big in any piece of software, I would always see exposing your database representation internals as a red flag, right? You never do that. You create a DTO that then is JSONified or whatever. But then blockchain, gas and all of that. In V1, we made a mistake of exposing directly what we store. That was a big problem, because if you want to upgrade something, you break your public API. It's really bad. So that's why we have, this is the instrument we expose, which has nothing to do, more or less, with the instrument we store. And that's why the mapping that stores that is private, because we created a getter. I think it's called instrument. Yeah, so this is like how we work around this time, that like we read from storage, we copy it into this memory object, and then we know that even if we decide to change this to add more stuff or whatnot in the future, we won't be breaking any public API. So yeah, this is all standard thing. We use UUPS proxies, so we need to be very careful with the storage. So what we did is like we reserved a lot of slots for ourselves. If we ever need them, we can always also add like stuff afterwards. And this thing exists because we deployed the first version of V2 in Arbitrum as a test, and then we had to do some changes, and there are some storage slots that we don't use anymore, but they had to stay because we have these deterministic addresses across all the networks, and we didn't want to lose that. So we just cope with these 4 storage slots. That's one cool thing that we do, is like to avoid ever messing up with storage. We use like the Foundry capabilities to introspect the blockchain. And so for each one of the things that we store in Contango, we have this test where, like, if we create an instrument, and we can go and read each one of the storage slots that the instrument uses. And because this is storage, we will be packing here. So these 2 things go together, these 2 things go together, and these 2 things will go together. So here, what we do is we read each one of the storage slots. We know how this is encoded, so we decoded it, and then we look at the code and see that everything is correct. And then we also have this failsafe. So if we ever add an extra field to the storage, which is not a problem, you can always append. The problem is when you remove. But this is a preventing against future self. So if I go and add something and I don't change the test is going to bark at me, which is what I want. Like if I change production code and the test doesn't break, something's wrong. So yeah, we have this test that is specifically for the storage in this contract, and for any other contract that is stateful and it is behind a proxy, we have the same. And then for the trading, it's not trivial. So let's start with the API. So when you call the trace function, you need to provide these two structs. We split what we call trade params from what is the execution params. And the main difference is that the trade params is what you would define as a user in the ticket. Like if I am creating or like if I'm editing a position, I'm going to have a position ID. Otherwise, the position ID is going to be 0. But we still have it always because we use custom types whenever possible, by the way, because it makes the code more readable and the compiler helps us a lot. So yeah, and I would put more if Solidity was better at it, to be honest. Like I think that when we like 0.20 got released by the time we finished with this, but I would have a type here for quantity and a different type for limit price, for example. And then my functions, this is something I inherited from when I was doing Scala. Like you put types everywhere, and then the type system prevents you from passing the wrong type or the wrong value whenever you're calling a function. So the compiler does a lot of the heavy lifting, and you don't have to write a test for that, which is brilliant because less code is always better code. Sorry, I interrupt you. But yeah, so we have this position ID, which is also, what is the name of the class? Position ID extension. So the position ID actually encodes a lot of information. So we have the symbol with the first 16 bytes. Then we have a 1 byte to identify which money market is this position associated with. Expiry, because right now we do perps, but the code is thought to also work with dated futures or expirables. And then flags. This is something we added because, again, gas. So we allow the UI or like the public client to tell us, like, for example, if we are interacting with Aave and the product is ETH, stake ETH, you should turn the flag on so we enable email under the hood. And so you get a nice 10x leverage. If it is again, Aave, and you are using an isolated mode, an isolated asset, or an asset that is in isolation mode, we need to turn that flag on. So instead of like querying Aave as part of the execution flow, we rely on the user telling this us. And it's safe because if you tell me the wrong data, Aave is going to reject the settings. So the only one losing out is whoever is calling this. And yeah, we have 4 bytes free for the future, and then 48 bits number. That means that we can have a lot of positions and it doesn't matter. So in the context of the API, when you want to create a position, like you have to encode all of that, but the last few bits are 0 because there is no position ID yet. Yes. So coming back to execution, sorry, I was describing like the two things. The second struct is execution params, and this is all related to or mainly related to the spot trade that we have to do, and the flash loan we have to take. So we build the system in a way that you can effectively have flash loans a la carte. So we have, I'm working, this was like a prototype of an ERC that now is becoming like a public goods thingy, and we like with a group of people we are deploying like wrappers in all the changes. But the cool thing about this API is that we define a standard for how we see a flash loan, and more importantly, we made it flexible in the sense that we can, instead of relying on our contract implementing a callback interface, which is very limiting because in our case, if you see here, we have 3 actions to perform. And so when we are opening a position, we take a flash loan, and finishing opening a position is totally different than closing a position. Like the flow is completely different. And like all the traditional flash loan APIs are very limiting because I have to have like a single entry point, and then in the call data have like an enum or something to know where to go. So the routing is a bit tricky. And the second restriction that all flash loans have is like they don't allow for the callback to return anything, which in our case we do allow the callback to return some bytes, which are then passed down to the caller of the flash loan. And this is very important because out of any trade, we want to return what happened with that trade. So we want to return what was the position ID that was created, and we want to return the trade itself, which is, it tells you like the quantity, effectively what swap did you do with the exact input, the output. You want to know the fees that you paid and a bunch of other details. So, I mean, you can always save that in storage and then retrieve it, but like it's really limiting the way flash nodes work nowadays. So for this, like we have like different implementations. So we have Balancer and Aave and Uniswap, all conforming to this interface. So we abstract all that complexity. And if there are more flash node providers in the future, we can go and use any of them. And more importantly, it's a responsibility of the caller to decide which flash loan provider they want to use. So that means that they can always err for like the cheapest, which is normally Balancer because it's free. But then the caller also has another responsibility, which is to tell us where and how to swap the money, right? So again, looping. We deposit some ETH, we borrow some DAI. We need to do something with the DAI, which is sell it for more ETH so we can, improve our collateralization. And so in V1, we were always using Uniswap. And so in V1, we didn't need flash loans because we were using flash swaps directly from Uniswap. The problem with flash swaps in Uniswap is that by design, they only work in a single pool. And for every permutation of assets, you don't necessarily have a single Uniswap pool that goes from A to B. For that, if you check in our GitHub, I created a POC of like a multi-pool flash swap. We ended up never using it, but it's really cool if you ever have that problem, because you can say, I want a flash swap from A to C, and you pass the path like when you do with like the multi-pool router in Uniswap, but now you have a nice flash swap working for you. So in V2, what we did is like, we noticed that there were like this, like, the guys from DeFi Llama started doing the multi-aggregator, and then the guys from Mean Finance started doing the multi-aggregator, and we were like, this is great because we can get always the best price for the user in any chain, and we don't have to worry. And luckily, like the Mean Finance guys, they open source their thing as an SDK, so our UI integrates with that, and it finds the best price possible for for the user for that particular quantity and that particular network. And of course, you need to tell the smart contract what to do. So you need to tell it how much to swap, what are like effectively the call data to pass to the aggregator, and where does the router. Spender exists because Paraswap, the contract you have to give allowance so they can take money from you is not the router, is a different one. So you sadly need two addresses. But yeah, so once we are here in the trade, and as you can see, trade and trade on behalf, they are exactly the same, just that trade defaults to message sender. We can see like if the depending on the sign of the quantity, that's something important. We use sign numbers in a bunch of places, which for what I've seen is not very standard in smart contracts, but we like to use sign numbers so you can always add up like an open trade with a closed trade, and they add up nicely to 0 or to the new position size, and then you can give meaning, like positive quantity means you are increasing your position, negative quantity means you are decreasing your position. Same with the cash flow. If you want to deposit money into your position, it's going to be positive. If you want to withdraw money from your position, it's going to be negative. So here we can rely on that information to say, hey, if the quantity is greater than 0, it means that we are opening. And opening means, it's a broader sense. It's open in the sense that it is a create or increase your position. In the same way that close is not just to fully close, it means that close your position partially or completely. And we also allow for modify. Modify means I don't want to touch my position size-wise, but I would like to either add more collateral because the market is going against me, but I don't want to close the position yet. Or it could also be the opposite. If the market went in your favor, and maybe you're hedging this position somewhere else, you may want to take money out of this position and then send it somewhere else. So we allow for the user to just modify the collateralization without touching the position, like the position, the notional size of the position. So yeah, so if we are in an open, we get or create a position. This means we are going to check if the position ID is 0. That means that we have to create it. And here you will see some interesting bit, which is that if we are creating a position, we will be minting an NFT. So effectively what we did is like we outsource ownership checks and ownership controls to a standard ERC 721 NFT. That means that this contract doesn't need to worry about who's owner of what. We just ask the NFT, is whoever is calling us the owner of this, of this NFT? Yes or no? And then we move on the basis of that. Yes. I think 88 MPH did the same and a bunch of others. We did this from V1 because we also have the vision for which you could use this NFT as a way, as collateral somewhere else, or as a way to net off your collateral. Because I don't know, if I have a long position in Maker, I could also supplement it with like a short position on my collateral. So the PNLs should even out. Or even like you can decide to sell your position from outside contango and like give your position to somebody else, and you're effectively giving whatever that position is worth to someone else. So yeah, and it's also, we don't have to write a lot of code, so it's a win-win. this thing here, like we use not heavily, but we use whenever possible this feature of Solidity of like extension methods. So it should be validations, I think. Yes. So these are like functions that are like freestanding, and they encapsulate like how we interact with the NFT. And we abstracted like this because A, like again, code reading like a book. B, because we use this in a bunch of places. And C, because it's really nice to say, hey, NFT, please verify this position ID for me. And like it increased code readability quite a bit in my opinion. Another thing that we have to do is to figure like which money market we are going to be using. I'll get to the money markets later. So I don't want to go into like the particulars of each branch of the code because it's extremely complex. Like we have a spreadsheet with, I think, 32 or 34 scenarios, which is like all the permutations on what the user can do, like open a position with collateral in base or with collateral in quote, increase the position, add more collateral than what you need, remove, because like it's crazy. Like, and we cover all those scenarios. In V1, we decided to go just for a subset of that, and it was quite limiting as well. So we decided this time we're going to spend the time and the effort into implementing and testing each one of them. And like we have a test that refers to that spreadsheet and says we have the scenario 1 with a brief description, scenario 2, scenario 3, scenario infinite. So we have like this tabulated, we have the spreadsheet to follow as a base, and then this is an abstract contract because we go and say afterwards, okay, now that I have all those tests in a generic way, I want to run all those tests on Arbitrum for Aave with this pair, right? And then I can do the same with Optimism. I can do the same with Polygon. I can do the same with Mainnet and Compound, which is one of the money markets that we have not audited yet. So it's not part of the public repo, nor is part of the UI or anything. It's not even deployed. So yeah, we may release Sun at some point. It really depends on how we see the user demand and what is that where we see the market going to, right? So those are mostly prototypes that we have to still iron out a bit. And we can do all of that because in the same way we abstracted the flash loans, we also decided to abstract a money market. So we went through a bunch of them and we say, okay, what is that we need to do with a money market? And in a nutshell, we know that we need these 4 basic operations. We know that for some money markets, we need to be able to claim rewards. And we know that we need to know how much money the user has as collateral in that money market. And initialization, because stuff like Aave needs E-mode or stuff like that. But the cool thing about all of this is that we define this interface, and then we can have all these implementations that just define like how do I do this in particular with it? Like, I don't know. If I open the Aave one, it's like, okay, how do I check the balance in Aave? Well, I have to do this. How do I lend in Aave? Well, I have to do this, and I have some branching here. How do I borrow? How do I repay? Like exactly, which is the other money market we have audited, is same but similar but different because they have they create like a different contract per asset, and so we had to create like a reverse lookup. But in the end, we always managed to synthesize these operations in this interface, which means that adding a new money market for us is a few days worth of Solidity dev and then auditing. So it allows us to move very quickly, very, very, very quickly. And so here, as you can see, we couple to this interface, and then we can do stuff. Another cool thing that we did is that we defined like the money market extends from ERC 165. And so we can ask if the money market has extra capabilities. And in our case, like for Aave, we have this extra capability, which is something we call flash borrow, which is a cool thing from Aave that you can request like a flash loan. A flash loan in Aave, normally you have to pay for, which is not nice. But if you request a flash loan and instead of paying it back at the end of the cycle, you actually deposit collateral, then instead of like a flash loan, it's effectively a borrow where they gave you the money before you supply the collateral. So that's why we call it flash borrow. And in that case, it's free. So if that's available, then we use that because A is free and B is less gas because we don't have to call another third party for the flash loan money. And this is where like the thing that the interface we did kind of shines, because we say either if it is a flash borrow or a flash loan, we can say, okay, I want all this money. This of course is an internal function, but it doesn't really matter. The thing is, like, here we are in the opening flow, right? So when we request the flash loan, we can say, hey, I want you to call me back here. This is the date I want to give it to you, and then you're gonna give me back some bytes. And I know that then with these bytes, I will be able to parse them back into this trade object that till here we return this trade, everything returns this trade, and then in the end, sorry, this is the trade. This is already parsed. No, we are parsing it here. Yeah. So we validate that the result from the flash loan is not suspicious. So we hash it and stuff, and then we Aave decode it into a trade. So that means that we can have like the full back and forth, and from the outside, it's just a standard function that you call and it returns something, and it's not broken by the fact that you have this callback in the middle. Again, we have a bunch of internal functions for validations and stuff, all coming from the code reading as a book whenever possible. And so this is the open function. So this is where we initiate the flash loan. It's like the simplest. It's validations plus calling the flash loan. We have these two callbacks depending if we are using a flash borrow or a flash loan. And in the end, we end up with complete open, which does all the heavy lifting. It goes and swaps. It would take money from the user first, and then it will do some checks, and then, you know, it will effectively get the money from the flash loan, buy the collateral asset, send it to Aave, and then borrow whatever we need to pay back the swap. Not strictly in that order, but I really don't want to go into all this logic because it's like it took us a while to get it into our head because it's extremely complicated, like all the permutations. So yeah, my hope is that like looking at the code is it should be extremely simple, right? Handle positive cash flow means, okay, as I explained, the sign means that we need to take money from the user. So this guy is gonna be getting money from the user. Something to notice is that it's not getting it directly from the user. This contract never interacts with the user. It interacts always with the vault. So we only have one place where we actually handle money with third parties, which simplifies a lot like the security. And yeah, coming back to complete open, executing the swap, again, this hides the fact that we check, okay, do I have to do a swap? Then what am I buying? What am I selling? And then we have this very simple contract that is a spot executor, which is in charge of just calling the call data. This is here mainly to for security, right? If we had Contango calling the swap bytes, we would be allowing Contango calling any address, right, with any call data. So we either have to put a whitelist, which means we have to put our signature of we trust these guys, or um, yeah, it's a big problem because Contango is in the whitelist of Contango contracts, so it has a lot of permissions. It can actually get money from that belongs to the user and do anything with it. So we don't want anything that is not pre-programmed to happen on behalf of Contango. So by delegating the execution to this spot executor, it means that the message sender and everything that gets to call to execute the call data is this spot executor, which has like zero permissions, is like a silly contract in the blockchain. So it doesn't have permissions to do anything other than, executing the swap. So that breaks the permission chain, or like the message sender chain, and means that Contango only does what is written here and nothing else. And then, yeah, again, I think it's fairly clear. Like the all like it's not as simple as borrow, swap, and lend, because as I said, we have all these permutations. So sometimes you are borrowing and at the same time repaying some debt in case that you're increasing a position and putting a lot of collateral. You may be doing the same when you are decreasing a position. So you may decrease a position, but also add collateral to it, which in our case means burning debt. And depending on like the kind of collateral you are adding, you may or may not need to swap that collateral. So it got so confusing that we stopped calling that thing collateral and we call it cash flow in the code, because it's also confusing in the sense that from a user in our UI, when you open the position and say deposit like 50 DAI, like I was showing, that for you is the collateral. But when you go and build the position in Aave, the actual collateral is the ETH we are going to be depositing in Aave. So we need to distinguish those concepts. And yeah, I don't want to get into this contract much more. Then we have the maestro, which, as I said, is the orchestrator. And like the whole point of the maestro is that we can create atomic combinations of actions and remove all those responsibilities from Contango, so we can deposit money or withdraw money from the vault. And we can use permit, we can use permit 2, we can use whatever, but we can also combine those things. And the reason why we have all this it's not a full Cartesian product, but like what we thought and think it was like the most useful is the code is optimized for layer 2s. And in layer 2s, you want to get the call data as small as possible. So instead of like using batching, which this contract is also capable of, it's just that it's like it's the plan B and not the plan A. We try to have like succinct functions that represent the intention of the user, and they execute like multiple actions at once, like deposit and trade. Okay, I'm gonna do some checks. The call data already tells me which token are you gonna be depositing based on like I can infer it from the trade params, so I don't need the parameters you would be passing to deposit, and so I can do that for less in a single transaction, and that means that from the UI you can, for example, open a position and at the same time set up linked orders for automation. So I open a position at this price and I want to close the position when the market reaches $30 more or whatever. Yeah, and it also allows for like just only placing linked orders, which again, like this is all handled by what we call the order manager. But we have this orchestrator that allows us to combine all these actions into one place in a very succinct way. What else that could be interesting? Yeah, I don't know. We did a lot of abstractions like this two array thingy because Balancer and Aave are very array based. So it's really ugly how you can, because in Solidity you cannot just open square brackets and create an array, right? For some reason. So so we created this nice hack so our code doesn't look ugly. Um, yeah, I have no idea because the compiler can see this. Uh, no, no, it should not. I don't know. I really don't know. I guess there are not many people using arrays to complain about. I have no idea, but we had a lot of things just to cope with the limitations of Solidity, to be honest. We have a lot of gymnastics around it. Um, yeah, yeah. We need the Rust guys to go and implement Solidity in Rust, like the compiler. So first of all, it's faster, but easier to, well, not necessarily faster, but definitely easier to maintain. Um, yeah, I don't know if you have questions or something you feel is missing because I tend to speak a lot and diverge. Okay. We like the product is live. So when I show you before, it was like looking at localhost, but like so if you go to contango XYZ, it's just your standard landing page, and then the launch app will bring you to this same website. So all of this is working. This is what is deployed right now. So as you can see, we are live in Arbitrum and Optimism. This sneak peek is like mainnet and Polygon, which we are releasing most likely on Monday. So we have already like a beta version that we gave to some users we have in Discord that they do like the early not testing, but um, yeah, they play with it first. And yeah, so like the product is fully audited, like in GitHub dot slash contango. I think that's what I said. I use it from another browser. So you can see the public repository for V2 is, of course, core V2. And here you can also find like the PDF with the audit that AVDK finished like a month ago. And so the repo I was showing is not this one. Is like, so we have this repo that is very static, and we only publish the code that is audited and live. And then we have the private repo where we have all the code plus our UI, like our bots, and the graph, which is where we do some of the accounting. We even created like an SDK for like if in the future third parties want to integrate, but right now it's handy because we have like two bots to do all the automation and also to do the charting. So this data is not something we are consuming from an API. We actually go and sorry, I lost you. I don't know in which browser you are. Oh, Chrome. Yeah, it's a mess. Yeah, so here we are plotting Chainlink. Literally, we go and scrap like all the Chainlink events for ETH and for USD. Then we combine the price feed and we plot this. That's why we only reach to 15 minutes because Chainlink doesn't update that often. So a 5-minute chart sometimes looks extremely odd. So yeah, we have a bot doing that. Then we have another bot that is constantly looking at any orders. So for example, here I have this order that says this position that I entered when ETH was at 1646, sorry. And then I have this, if it reaches 1700, please take profit. If it reaches 1500, I want to cut my losses. This is because my liquidation point, I mean, this is risky. I'm just testing what's going to happen. But if the position is still there, Aave will liquidate at this price, this thing. So I really want to see how good the bot is. But of course, for any position that is not a testing one, I would put a buffer of like 3-5% on your stop loss just to just to avoid any hiccups. Um, then we have these positions like stake ETH, where I'm basically collecting the positive funding rate that I get. Lido pays me more than what I'm paying Aave for borrowing ETH, and we consider this in the APR. So like it's telling you, yeah, I'm making a 169% a year over my whole position. So in a year's time, I should have 1.016 of ETH. But I also say, because this is also represented in like the exchange rate between wrap stake ETH and ETH. So I also have a take profit that says if the market price reaches 115, just close it. Again, this is my test account, so a lot of the things don't make sense. And I am a really crappy trader. As you can see, all my P&Ls are red. That's why I stick right in Solidity and not trading. Yes. Um, but yeah. I mean, what we like, our goal in the end is like we want our product is mainly focused on UX, right? What we want is like people having a trading experience that is as close as we can get to what you get in Binance or the YDX, but with the native way of having leverage on DeFi, which is looping or like folding into in money markets. And yeah, the UI is like we release pretty much every day. I became a UI developer lately. So I've been doing a lot of the features myself. Because of course, like Solidity, once it's audited and everything, yeah, the change rate is very slow. So yeah, we will be adding more features. We already have like a new layout that is a little. Like this is a bit too big for my taste, so we are gonna give it a renovation, and yeah, and we have a lot of features in the pipeline, but we wanted to release with something that works, and then grow slowly and steady. But yeah, hopefully what I said makes sense for the viewers. No worries. Twitter, yes. Thanks to you. It was a pleasure. Bye bye.